Hello and welcome to another tutorial. So this time around we are going to be taking a look at the AI navigation package in Unity, and in particular the NavMesh surfaces. So this is an updated version of the NavMesh tools, and they allow us to do some actually pretty cool things. So we're going to be able to support having AIs walk on walls. We're going to take a look at what's actually involved in that and set up a bit of a sort of standard setup for us to be able to be using there for doing this. So let's dive on in. So first thing I need to do is I need to actually bring in that package. So if I go to Package Manager, and then I'm looking for ones in the Unity registry. So the one that I'm after is this AI navigation one. So I want to bring that in because this allows us to do a whole bunch of different things, but there's some particularly cool things that it will allow us to do. So what I'm going to do to start with is I'm going to create an empty object here that I'm going to call NavMesh data, like that. And then I'm going to create an empty child under that, and naming wise I'm going to name this based upon essentially what the up direction is. So this one, the up direction is positive Y, and I'm going to give it a NavMesh surface component. So if I build this, we'll see in the inspector it generates a bunch of data. Now you'll notice I've got these, and they might be a little hard to see, but circles here going down to circles on the ground. So there's a bunch of things that we can configure for the NavMesh surfaces. One of the things is this agent type. So it describes essentially the characteristics and the capabilities of the AI, the character that's going to be using the NavMesh. So I can go and open the agent settings, and I'm going to bring the navigation tab here. So we can add in additional agents, we can change the name of them, and it shows sort of the key things that we generally configure. One is the radius of it. The other is the height. We have the height that it can step up. And crucial thing here is this drop height and jump distance. So it will actually automatically generate jumps and drop down maneuvers if we enable them here and if we configure an appropriate height. So if I actually bring this closer and then go back and rebake the NavMesh, can see it's now generated links between these. So we can make it so that we can easily support doing things like that, which is really handy. So with these settings, you've usually got a bit of leeway with the size of the character. So it doesn't mean that any character using humanoid has to be exactly a radius of 0.5 and has to be exactly a height of 2. You can have ones that are a bit sort of smaller than that is generally going to work pretty reliably. Larger than that, you can run into issues. The main things that you'll run into is, say we had something that was 1 meter high and it was using this. It's going to function as if it is 2 meters high, which means areas that it might be able to duck under, because it's shorter, it won't be able to. The same would happen if we had something that was 3 meters high and we're building with the 2 meter resolution. It would have doorways that it thinks it can go through, and it might try to, but it can't physically fit. So you've got a bit of leeway there, but you do need to be mindful of those problems that you might run into where something will not be able to move through an area that it should be able to, or it might try and move through an area that it actually can't. So just something to be aware of, and it's something to settle on early on with the project. Now you can create multiple different nav meshes supporting different agent sizes. That's absolutely possible. but you just want to be mindful of sort of what the sets of sizes that you're likely to have are, so that you're only generating the data that you need. It can be a real nightmare if you get to the end of the project and things are quite different. I've had that happen on a project before, so it's something that try and lock down early on is really important. So we can configure our different agent types here. We can select what agent type it's building for. So I'm actually going to rename this to humanoid NavMesh data, because that's actually what we're building here. Because we could be adding in a different agent type and only building the data for that. We've got a lot of different options there. And areas can be marked as different types, and we do have these area settings. So these are handy. You can add in things that have different costs. So you can mark different surfaces up like that so they're more expensive. So there's some really handy things that we can be doing there. But there's a reason I named this positive Y. And the reason is, and I'll actually move these, not that it matters, but I'll rebuild it with that centered. Because I think that's one that makes sense for it to be at the origin. So there's a very specific reason I did this. And we'll get, so we've got the thing in view. So I'm going to copy that, and then I'm going to rename that to positive X. So facing into the screen, so towards the back wall here. And then what I am going to do is I am going to rotate this. And whoops. So what I'm going to do is I'm going to rotate this so that Y is facing in that direction. And then I am going to, again, bake that data. And you'll see we've got NavMesh now on that wall. So, okay, we've got positive Y, we've got positive X. Well, let's get negative X set up. And not surprisingly, we rotate this the other way. And then go bake. So, okay. So far, so good. We're going to, up here, do neg Y. So for that, we want our Y-axis, the green one, pointing down. So I'm going to rotate that by 180. Oops. Always keep doing the position offset. By 180. And we're going to bake that. Now, a lot of the data, like we won't be able to see it in areas, but we can see we've got it building here. We won't see it underneath because of where the collision is located for this. So we'll see little bits here, but the main ground plane we won't see it for. So, okay, we've got on the ceilings and on a couple of the walls. And let's get the last couple of ones going. So this is going to be positive Z. So again, similar thing. I'll reset this back, and I want it pointing so that the Y is along the Z axis, like that, and that's the positive Z. And then I'm going to duplicate that for negative Z and flip the rotation. Now I'm going to just select all of these and bake. And now we have navigation mesh on every single surface, which is really handy. Now I'm going to probably tune down the jump distance here because we've got a lot of ones where it's generating stuff there that doesn't look ideal. So you can see it's eliminated those jump connections there. We've got a few ones here with these jumps, which might actually be okay, so I might reset that back to 2 and then bake it. So it's handy that we can select all of them. So this, I'm actually going to then turn this into a prefab. So we'll create a folder here, prefabs, like this. So, okay, we've got a prefab then that we could throw into any level where we have humanoids, and it will give us all of the things we need to build path data on all the surfaces, so walls, floor, ceiling, you name it, we've got the data built. So, okay, we haven't tried doing the moving yet. We'll get to that. The moving's actually really easy. Most of the work is handled for us, and actually, this is the main thing we needed to do to be able to support walking on walls. It's actually very little beyond that. Now, the other handy things we've got here is in AI, we've got the surface that we've obviously already used. We've got modifier volumes and links. So let's take a look at having a modifier volume. So I'm just going to put this like that. So, okay, we'll bring it over to here. And remember these areas? So I'm going to call this swamp, for example, and give it a cost of 3. And then we're going to say, mark this area as, whoops, it would help if I spelt it correctly. Let's fix that up. So swamp. And we've said that it affects all agents. So whichever ones build in this area, it's going to mark that as swamp. So let's build our data. And we've got the different color there because we've marked that area as swamp. So it makes it really handy for being able to indicate different types for an area, and adding different costs. So it doesn't ensure that the AI will move around it, but it makes it more expensive for moving through sort of that area. Or we could make it cheaper. So there's a lot of different options that we've got there with it. But let's get this AI actually moving. So, okay, our AI character, I just want to set up a very, very simple script on it to support doing the moving. So I'm just going to create a script here. Simple AI character. And very little actually changes with how we work with this. There's not a lot that is actually different. So it's using a fairly standard setup. We've got a character controller on it. We have our NavMesh agent. We've set the agent type. So most of those settings are pretty much the standard sort of ones you would use. I'm just going to position it so that it's here on the ground to start with. So same NavMesh agent we normally use, works exactly the same way. Now let's set up this script. So what I want this script to be able to do is I want it to be able to, I click on a location and it moves towards that. That's pretty much the basics of what I want it to be able to do. So I'm going to require component here, and we'll require component and a type of NavMesh agent, like that. Just so it's mandatory that it has to have that, because it makes sense for requiring it. And I do recommend, in cases like this where it makes no sense for it to ever not have that particular component, I do strongly recommend using something like that. So, okay, what I am going to do is I'm going to keep track here of our NavMesh agent, linked agent, and what I will do is in awake, I'm going to retrieve that. Just like that. So that's good. And then what I want is to be able to set its destination. And I want to know if it's already got a destination set. So I'm going to have a Boolean here, destination set, which I'll default to false. And then what I'm going to do is in this, I'm going to give it a function, a public void move to, that takes a vector3 of a new destination. And then I'm going to, doesn't actually have to do too much with this when we're actually picking a location. Now, what I could do is I could just directly go, okay, well, agent set destination and give it that. And we'll set destination set to true. So I could just do that. But if we click in an area that's a little bit away, then it means that it's potentially never going to get there. So what I would normally do is a NavMesh hit result, and we'll go f NavMesh sample position, new destination, out hit result, and we want to have a search range. So I'm going to set up here, serialize field, float nearest point search range. And I'm going to make that actually not too large, because one of the things with building NavMesh on multiple surfaces is it could be very easy for us to actually pick the wrong NavMesh if that range is too large. So I want to try and actually make it more difficult for that to happen. So then we have NavMesh and all areas. So that looks good. So we've got our sample position, and we've provided we haven't provided the search range, which is why it is grumpy at us. And then all I would do is I only set the destination in this case, and what I set it to is hit result position. So if we've found a valid location, then we try and move towards it. Because otherwise, it is something that we can handle, but it gets a little bit more complex for doing that. And then I want to check, have we actually reached the destination? If we have, then how we'll know that is if the linked agent does not have a path pending, so it's not trying to find a path. And we want to also check, because we could be on one of those links, those jumps. So that on-off mesh link is what they're referred to as. We want to make sure we're not looking for a path, we're not on an off mesh link, and then we check the remaining distance is less than or equal to our stopping distance. So it means a few things that we need to check. And we'll set that then to false. So it's a bunch of things that we do need to check, but that is actually a very necessary thing for us to do because there's a few different stages, because it will actually go through the path finding, and then it will go through the path following. And when it's searching for a path and then following it, it could be on off-mesh links. So we want to be very cautious about making sure we only set the destination as reached when we know the conditions are valid for actually checking this remaining distance. It's one of the downsides with the NavMesh agent, that it is a little bit of a hassle in that regard, that there is a lot more things that you need to check just for reliability there. So, okay, so far so good. Now I want to be able to tell it to go to locations though. So what I'm going to do is I'm going to, and I'll put this separately. The reason being that I don't want this on the actual character itself. And I'll create a script here. Just have a separate folder for general script. And this is going to be interaction manager. And I'm going to put simple there because it is a very simple one. And its job is going to be that I can click on a location and we will move to there. And I'll reset these because they shouldn't have a, should just be at the origin, and put those near the top as well, just because it's something that is a sort of common to the level. So that's usually what I do, is things that are more managery type things, tend to put them towards the top of the hierarchy. Just makes them easier for me finding them. So, okay, simple interaction manager. So I'm just going to set this up so it's not directly working with the new input system. It's just going to use the built-in, the sort of legacy one that's there, just for speed of getting it up and running. So I have simple AI character, linked character, like that. I want to be able to define a mask of what layers it actually checks. So I want to be able to have a layer mask, raycast mask, and to have it select all of the layers by default, we just do ~0. I want to only raycast out to a certain distance, raycast range, and we'll set that to 100. So, okay, good so far. Then in update, well, if input get mouse button down, so we want to handle either button. So we'll go for 0 or 1, like that. So if that's the case, then what I want to do is I want to work out where we actually hit. So I want to convert the mouse location to a ray. So what we do is we have our camera ray, and we can go camera.main, screen point to ray like that. That gives us a ray now that what we can do is we perform the raycast, and we have raycast hit info, and then we just go and do our usual physics raycast. We give it the camera ray, we give it the hit info. Now we want to give it the raycast range, the raycast mask, and we're specifically going to ignore triggers. I want to only be colliding with things that actually have full collision on them. And then what I'm going to do is linked character, move to, and the hit info point. So that should pretty much do the trick. We should have that be able to be moving to locations. And that we're working with to set that, so that's all good. So let's test out what happens. And we've got a character selected. So we're running. So we did not link up our character, I believe. Yep. So it always helps if you link up the character. So now if I click, it moves. Now remember, we had a higher cost here. So if I click up here, it's moving through the swamp area, and you'll notice it moves around it. And if we go to the scene view, See, it tries to actually skirt around it. I can tell it to move into it if I need to, and it will sort of circle around towards it, but it does try and avoid moving through that area, which is really handy. And we can do further sort of tweaks with this if we want, because actually at the moment, that agent, if we go and take a look on the character, the areas, it's not allowed to actually even go into the swamp one, which is why it's sort of staying on the outside. So if I turn that on, and then now we run, so we can see it does still sort of skirt around it. It can move into it, and it tries to get out of it as quickly as it possibly can, so there's a higher penalty for that. If I try and directly move through it, you can see it skirts just around the edge of it. So we've got our areas and things like that working. But at the moment, if I go and click on a wall, for example, it doesn't actually manage to walk there. It's staying on the actual ground. So what I need to do to allow it to transition onto these walls, and I'm going to move this obstacle out of the way. What I need to do is, this is where I create a NavMesh link. And what I'm going to also do is, just as a child of that, put in a sphere. Just makes it a little bit easier for positioning the link. So that looks good. And what I do, position it about there and about there. That looks good. So I'll get rid of the sphere once I'm done with it, but it just makes it a little bit easier for configuring it. So these have these little points. You can see these orange sort of squares. So what I'm going to do is the end point, which is this one here, I'm going to make it so that that end point is up on the wall. So we've aligned this to the wall. We'll go for maybe 1. So it's sitting up there on the wall. This one can make it so that it's fairly close to the wall like that. And then what we can do is we can adjust the width. You see how we've got this boundary being shown there. It's a little bit difficult to sort of see. If I come down here, we can see just this faint color. Now what I'll actually do is I'll set up an area and I will call this transitions. And I will change this to a transition so that it's going to be treated slightly differently. I'll modify the AI character to support those. So we've got transitions there. We want to make them a little bit more expensive. It shouldn't go on the walls and things like that unless we're absolutely needing it to. So that will mean that it should be able to get up onto that wall now. And I can add in a couple of other ones now that I've got that set up. What I could do, and you'll see when I'm away from the wall, it goes transparent. So it's handy to tell when it's actually working. So what I can do is bring this over and I'll connect it up to this wall like that. Now this is going to have an even larger width, so we can expand that width even further. It doesn't have to be super wide, but what this is that essentially is saying here's the area that it's able to safely move through. So you don't have to do that, but I tend to do that to make it a little bit easier to actually sort of have them transition whenever you want them to. So it does mean you have to manually mark these up, but it is something that the end result, as we'll see, is pretty darn cool. So because I can rotate these, I want to rotate this so that it is vertical like that. So that'll be 90, and we'll rotate it around 90 as well, like that, I think. So the goal of this one is going to be to connect these two walls. That's sort of what we're trying to connect with this. So we can see that surface is a little bit off. We need to have it more around there. We can reduce the width because it's currently a little bit ridiculous. So let's reduce that a bit more. And we can see it has colored it in, which means it has linked to the surfaces, which is good. Can position it a little better. That looks pretty good. We can see where the start and end points are there. So that looks good. I'll turn off the spheres. I'm going to still leave them there because they do make positioning things a little bit easier. So we've set up all of these surfaces and everything, and we've set up the links. But what we'll notice if we play this and we tell it to go to like the wall here, nothing happens. So we need to actually detect and handle that it's trying to go onto an off-mesh link. So what we do is here in our update, we're going to go and check, well, if linked agent is on off-mesh link, and we want to check if we've actually started it. So, okay, I'm going to set up a tracking for off-mesh link in progress. So if we're on an off-mesh link and off-mesh link in progress is not true, so we haven't actually started one, then what I'm going to do is I'm going to set up a little coroutine here and follow off-mesh link. I'll follow the same naming, and this will just be a lerp. And the reason I'm naming it like that is we could set up completely different ones if we wish to. So we're going to go start coroutine, follow off-mesh link lerp, and what I will do is I will actually set here that the off-mesh link is in progress. So then what we do for this is we are going to take control of things. So linked agent, update position is going to be false. Linked agent, its updating of rotation is going to be under our control. And for now, the up axis will also put under our control. And then what I want to do is I want to just move along the path. So, okay, what I want to have is a vector 3 new position. And that's going to start at our current one. And then we're going to have a while loop. And we're going to check if we are approximately at the end position. So approximately, and we're going to get the vector 3, and we'll go our square distance, square magnitude of our destination position. So we can go agent off-mesh link. So it's the current off-mesh link data and the end position, which I might put this at a separate variable just to make it a little bit neater. This will be a vector 3, and this is our end position. So we'll do end position minus our current location. So end pos like that. So f, that square magnitude is approximately 0. Well, we'll continue until it's approximately 0. So what we do is our new position is a vector 3 move towards from our transform position to the end position, and we're going to do that at agent speed by time dot delta time, so however long has elapsed. And then we'll just go transform dot position is equal to that. So just a very simple move, and then we'll do a yield return new, and we just wait for the end of frame. Once we're done with that, then we're going to say, okay, well, off mesh link in progress is false. We're going to be able to say, okay, we've completed that link. So we go complete off mesh link, and then all of these ones here that we set to false, we're going to set those back to true. So we just give back control. So essentially what we're doing is while we're on those off-mesh links or navigation links, we take full control of the movement, and then as soon as we're done, we give control back to the NavMesh agent. So let's test this out then. So we'll run. So we're going to tell it to go to the wall here, and we can see it ends up walking on the wall. We can click on different locations and it's going to move to them. If we start over here and then click on the wall, see it has a little bit of difficulty with picking the particular surfaces. So we do want to, generally if you're having any difficulty with it picking stuff, one of the first things I would do is clear and rebake the NavMesh data. That's one of the big things that I would make sure that you do, because it's very easy for that to be causing issues. And we just want to check with this that it's actually properly linked over. So we'll just have it, generally you want the blue sort of embedded a little bit in both, is usually what we're looking for with it. So we'll make sure we've done that for all of these. We'll just give these a little bit more leeway, and that should make them work a little bit more reliably. So that's good. And I have intentionally made the walls quite a bit thicker here, just because it's very easy for it to end up picking the wrong data. So we'll try and move to a location here. We can see it's up on the wall, and it can move around, can move down here. So that's good. If we start it up on the actual platform here though, so we're going to bring this up here like that. It's going to start just on the platform. And what we will do is rebake the data. So we've moved the character up to the platform here, and I did rebake the path data, and you notice the gap that was here is also up here, and that's because the character is getting included in that build process. So what I can do is I can add a NavMesh modifier, and the mode can be remove object, and we apply to all children. And then what I will find is if I go and rebuild the data, it's now no longer blocking geometry there, which is good. Always helpful to have it not doing that. So, okay, we've got all of our data. I'm just going to rebake so I can see everything. And we can see these jump links here. And those are auto-generated off-mesh links. We've added in the support for following the links. We can see, we can easily go through and it does the jumps. We can move down. We can click on this wall here. It'll move to that. Can move between walls. Now, we haven't done anything fancy with the actual handling of sort of up direction. That does fix up the up direction, but that is something that we would need to do further refinement of, but it depends upon how you want your AIs to look when they're moving between surfaces. But we've got this working. We've seen how we can add in areas that cost more, that they'll, we can have them avoid it, or we could have it just be more expensive, or we could have things be cheaper. So you could do things like, if you've got a city, roads could be really expensive for pedestrians walking along, but footpaths are really cheap, and pedestrian crossings could be cheap as well. That'll just tend to naturally funnel people through those areas. So it can work really well for being able to have the movement look more natural, more realistic, without actually having to do very much. And we've got a handy little prefab that we can use for building data for any of the surfaces. We do have to add in these links for each particular connection that we want to have. And I do recommend giving them their own area ID and a slightly higher cost, just so that, the AI isn't transitioning onto the surfaces at points in time that look and feel weird. But we've got this working. So I highly recommend checking out the new AI package that exposes a lot of this stuff. It's really, really handy, works really well, and lets us do some quite cool things there. Thanks, folks. Hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you're looking for the code for the project, that code is available up on GitHub. There is a link to that in the description below, and you can freely use this code in any of your own projects, commercial or non-commercial ones. If you've got any questions, chuck in a comment below. If there's other features and functionality with this you'd like to see, then also chuck in a comment about that. And if you're looking for other ways to support the channel, then I do have a Patreon as well, and there's a link to that in the description also. But until next time, bye!